All right, well, good afternoon, everyone. My name is Shawn Wallace. I'm with Centric Consulting. We are a regional consulting firm. So I'm an architect in the Columbus Business Unit. I work on our technology practices. I've been doing this for a long time. I've always worked for either a product company or a consulting company, and I haven't had that many jobs in like a 25-year career. I've had like 5. So I've worked for 2 product companies and 4, I think. That doesn't add up, right? But I have worked for 4 consulting companies, so I didn't do the math in the beginning. So what I do is I help people with technology stuff. I started out as a developer, became an architect. I had my own product company for 9 years. So what we do is we do kind of a lot of application development, a lot of architecture. So what we're going to talk about some specific implementation patterns or around event-driven architecture. It's come with a lot of pain, our experience. We've been doing this about 5 years. We've been orchestrating applications this way for about 5 years. As the cliche goes, your mileage may vary. You've got to think for yourself and find out what works for you. You remember the old axiom from SQL development: normalize till it works, denormalize till it works. There's no perfect solution, right? What we're going to talk about, we're going to talk about some patterns and some things that have worked for us, and some of the things that have gone well for us, and kind of where the future is going. We'll end up where that is. And check this out. Isn't that cool? My first time using that, so we'll see how that works. So before we get started, I want to have mention a word about productizing patterns. Way back when I worked for a consulting company, I still work for the same consulting company, Centric. We decided to make a product around agile development. We called it agile development for the enterprise, agile for the enterprise. What consulting companies do, and they screw everything up, is that they try to create these standard patterns or practices around a design pattern or around a business practice, right? And then I give you a book, you follow the book, you're going to do everything right. That's not what's going on. So we've got to think for ourselves. I was talking to some developers yesterday on one of the teams that I'm working with, and we're talking about unit testing, and they said, well, can you write me an interface that I can implement, that I can inherit, that I can implement, that will tell me all the tests that I need to write at least? And I told them, no, you've got to think for yourself. What is the requirements that you're trying to implement? Now, I came back and said, there are some tests that we want to do for certain kinds of things, so we can entertain the article because they're smarter than I am too. So there's some good points there. But we're not trying to productize a pattern. We're trying to use a pattern and apply it to different situations, which means we need to understand the pattern, how to apply it, why to apply it, and know when to break the rules. Okay? Because sometimes we enter edge cases that cause us to have to break the rules. So we'll start with this kind of debate. I've showed this slide before. Some years ago, Martin Fowler published an article about, and it was called Monolith First. Let's start from a monolith, and then let's move to a services-based or microservices-based architecture. And he published another article, and I think somebody else read it. Should we start with microservices first? Right. So that's kind of the debate, the thing that we want to that we kind of want to dispel. Our going in position right now is that we're starting from a microservices approach. We've had this discussion, and we've decided we want to be distributed, and there are a lot of reasons. We're going to talk about why those reasons are here in a second. I see, and it also seems like I hear a lot at conferences where people are saying that it's totally better to do a monolith, right? But I might disagree a little bit. So remember how these systems are built. We have one feature, one function. We don't build 200-page, 1,500-page requirements documents anymore. We've got an idea. We build an order system, and then we start adding other componentry into that system. And then we realize that we've got a tightly coupled system that's hard to deploy. It's hard to test. There's extreme risk in deployment, because what if we missed something and we screwed something up, we had a problem, then everything's down and everybody's down and they're yelling at me, and I don't work really well when people are yelling in this ear and this ear at the same time. You just pick one ear. 2 years, it's too much. So we thought of a problem. So how can we solve this? So what we did was we we saw that all this software is composed of smaller components. Well, what if these smaller components could become an application that sits by itself, and we could deploy that application independently, right? Our goal became to, well, how can we write a bunch of smaller applications that work together to present an orchestration? Now, we're not talking about building a system that's your that's your task list. We're talking about enterprise architecture, enterprise application design, multiple systems integrating together, performing multiple complex functionalities. It's hard to do this, but we can simplify our world by making smaller applications, and now we have our first bad word of the day. We went from monolithic to SOA. SOA became a bad word. Why? Productizing. Who bought a SOA product back in the day? Service-oriented architecture, right? And then we did a bad job at this. What we did was we took our application and we split it apart into these various components, and then we wired them all together like this. We had this one talk to that one, and that one talk to that one, and this one talks to this one, and sometimes I don't know who I need to talk to. So the problem is that we have all the same dependencies that we have in a monolith, except now we've introduced the awesomeness as having HTTP or some kind of call stack in the middle, messaging interface in the middle for which we call. So we've got other layers of abstraction. We are still very tightly coupled, okay? And we painted ourselves into a corner. I did a project for a university, a major university, not in Columbus that you've heard of. And one of their problems is that they would publish services, and they would get, say, student data. So student data came from the student database. So they would publish a service, and the law college would say, how can I get student data? Well, I can talk to the student service. And then the College of Engineering talks to his buddy in the law college and says, where can I get student data? Hey, I can expose student data to you, right? And then so on and so on. And sometimes, and then this data is replicated overnight. In this particular instance. So what happens? If you show up at this university and you're a student, you show up on day 0, you get your ID card to go to your key card to go to your room, you put it in the door, and the door doesn't open for 2 days because it takes 2 days for that to replicate. Ha ha ha, that's funny. You just got to get a buddy to open your door, your RA to let you in. But what if it's the person that you fired, right? If you fired the person and his key card doesn't stop working for 2 days, we've got real problems. So it's more than just these systems are hard to maintain, hard to support. We also can create real business problems that we can't support very well because of these supposedly loosely coupled services that end up being tightly coupled. And then I have dependencies. So whenever I do a deployment, who do I have to let know? Everybody that's consuming me. How do I know who all is consuming me? Well, I've got to go find some log files and all this other information. And, by the way, my data warehouse team wants to connect directly to my database to get data, so I can't do those changes. So that's okay. We'll keep those services. We'll introduce a different messaging infrastructure. We'll call it an enterprise service bus. So what we're going to do is everybody's going to talk to our ESB. And our ESB will take my data and very nicely maybe transform it and provide some orchestration and send it somewhere else, right? And then maybe take the result of what that process does and transform it a little bit and send it somewhere else. Well, we've got a few problems with ESBs as an orchestration. Anybody here working with ESBs or have worked with ESBs? It was super popular, and it kind of still is. I deal with it, come across it every once in a while. So the unobvious things are they're super expensive. Super expensive. Hundreds of thousands, $250,000 to get for annual license to an ESB. Lots of people like to customize the rules. They're hard to test. They're hard to get into production. When you deploy the ESB and new changes to the ESB, the whole thing comes down. Now, it's gotten better. And then the older that your version of the software is, the harder it is to get people that want to work on it. Okay? So it's the messaging infrastructure, but it's also the orchestration. And what happens is it's still tightly coupled. If I have to let everybody that I know, I have to notify everybody that I know that I'm going to be doing an update, then I've got a problem because sometimes there are people that I need to notify that I don't know. Does that make sense? Sometimes there's some kinds of people out there that I don't know that I need to notify them. So let's just replace the term ESB with a modern scalable message queue. All right, so the point here is that let's use that communication layer for just passing messages. That's all. It needs to stay up, and it needs to pass. It needs to pass messages. It needs to be scalable, and it needs to have a high level of uptime. All right, so there's a picture here, and I think Mr. Kloss, who used to be with us, who's dearly departed from our company, I think he came up with this image. Huh?
That's a copyright violation.
I work for Centric. That's a Centric thought. But anyway, so we're somewhere on a continuum from all the way over here. You know, we talk about monolith. We're really talking about mainframe, and then I saw a good talk today where it kind of went through the history of what we're talking about to client server. We're in this world right here. And if we're thinking about microservices, we're thinking about, you know, maybe Docker containers and maybe full-on functions. So what we're doing is we're living in this world, and you guys can probably look at your organization or the organizations that you work with, and you can see your place where you are in this map. Now, I lived here quite a bit. I hit the wrong button. Maybe I didn't. I lived here. I mostly skipped this part, and I jumped to right here. Okay, so that's kind of, and that's kind of the concept, a mix of the concept that we're going to be talking about today. This is, I didn't create it, so I can say this. This is picture worthy, but the deck will be published. It's been useful for me to use this tool to communicate with clients and certain leadership within my own company. All right, by the way, has anybody noticed the copious use of Magic Move in Keynote? So we're gonna talk about microservices today. I think probably most people are as a key component of the implementation of event-driven architectures. You know, they're independently testable and deployable. When I deploy them, I don't have to let people know. I love functions because I deploy them, and just the next time they run, they start coming up. They're stateless. They operate in isolation, and I like that they're asynchronous. I like that they're asynchronous and that they're fault tolerant. If they're set up in the right way, they scale. All the things that we like about microservices. So as we start to get into the concept of what EDA is, or event-driven architecture, there's a couple of decisions that we need to think about as we're designing the next system or the way that we're going to approach our work. There are some things that the first thing I want us to do is embrace asynchronous interactions. All right, so it's not point to point. It's not, hey, this is me, and then you give me an answer. It's I'm going to throw the message out into the universe and then wait for the response. And we have the trust. We trust that those things are going to happen. That depends on then a great communication pattern or a great event model, a way of passing messages. And it also requires a way that we need to make a decision about logging that tells us how these messages are, where they are, and where our process is with respect to state. Think an ordering system. I need to be able to look, if I've got a shipping system over here, an invoicing system, manufacturing system, and ERP over here, all these different systems, accounting, all the things. Pick whatever you want out of that. I've got to know where my stuff is in the process, right? I can't go to the shipping system and know how many orders I received today, right? So I've got to be able to have visualization into the process. And by the way, we haven't had that in a lot of our systems. The best way we can do that is to snapshot data and send it to the data warehouse and generate some reports. We're talking about live, how many orders do I have? Where are they at in the process? What's in shipping? What has an exception? Can I resend these things? These are all things that we can get out of our logging infrastructure. By the way, the last thing we're going to talk about today is event sourcing, which is really the logging infrastructure maybe I'm being too simplistic. Logging infrastructure on steroids, though, is what I will say. So we talk about, everybody's heard of Conway's law. The basic idea is that your software systems, funny how your software systems tend to mirror your org chart, right? If you have a shipping department, you generally have a software component that's called the shipping component, right? Well, that's okay. Let's embrace it. If they want to have this big piece of software that runs shipping, if accounting wants to have giant ERP called this, whatever, if the shipping department wants to build something custom that doesn't know how to call a web service or an API, that's okay. Let's embrace it. Let's understand that our organization is going to grow organically. So we don't necessarily have to know all the components as enterprise application architects, we just have to know what they can do and how they communicate with each other. And that's that's one of the things that we come back to. So we're going to embrace Conway's law. We're going to understand. We're not going to try and fight that and say, no, 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 no. You need a thing, and shipping can be part of the ERP system. And accounting's like, no, we want our own. And shipping says, I want another one. That's okay. Let's embrace it. Let them make those decisions. We're talking about orchestration of an entire process from beginning to end and monitoring throughout. Also, I want our applications, this is important to me, they need to be easy to test. What's the most important reason that our applications should be easy to test? What do you think? Just guess. Anybody? So that you will test them. If it's hard to test, you won't test them. It's, I argue, I go to a client site and they'll say, we want to do unit testing. Your stuff's not testable. That's why your guys aren't testing. It's really hard. There's a lot of friction. We have to refactor. Or we have to do all integration tests and integration tests, which we can do, but that's not the fastest. We need to be easy to test so that we do, because it's super important that when we deploy a component that we know as much as we can, as well as we can, that it's going to work properly. Okay? The best way to orchestrate your world is probably not APIs calling APIs. Okay, because there's a lot of things in the HTTP stack that can make that inefficient. It's another problem for us. It's another logging source, right? Sometimes our default should not be. And remember, we're making decisions. We're trying to come up with a decision. We're gonna. It's not that we won't have REST in our architecture. It's that we're going to favor not REST in our architecture, but not necessarily a native call. But sometimes the underlying infrastructure is still HTTP, but that's not the droid you're looking for. Code reuse is overrated. All right, so we're not, as architects, I have a component, and I have an interface, and the interface says a new order has to be a product, a quantity, and a price. And that's what's a new order. So I'm going to create an interface, and I'm going to ship it to all the teams so that they implement that interface, okay? Or I'm going to have a component. So I've got an API that I'm going to expose, and what I'm going to do is I'm going to create a component that abstracts the use of that API, and I'm going to ship it to all of my apps. I'm not saying that's always a bad idea, but I'm saying sometimes that is a bad. Sometimes it's okay that if you publish a model as a contract, that all the components in the universe or all the applications in your universe implement their own. It's okay to not push code to everybody. What that gives us a few things is, you might be all .NET. You might not be all .NET. You might be all Java. You might not be all Java. You might be. How do you push that model to an Angular website, right? So we've got to be able to answer those questions. What if you've got a team that wants to be building some stuff, doing some functional work where you can't send them a model, or they're deciding to work in Python because it's the best way to solve that problem. If we want to share all of our code, not that we shouldn't, we should have a bias to letting our teams choose the tools that they need within reason, right? Sometimes I'll show up at a client, hey, we need to use this tool, and like, that's cool, but I can't support it. Well, we can't use that tool, right? But we need to make sure it's not always that we have to reuse code, and we have to build these libraries and spend all this time up front designing things that we ship to everybody. Oh. Don't I need transactions? How do I deal with transactions if everything is asynchronous and decoupled, and we've kind of done inversion of control on the whole enterprise where things don't depend on each other, right? So we have to have an answer for this. How can we do transactions? If we send something to the shipping company to say, hey, get ready to ship something, and then the inventory system says, sorry, well, we don't have it, how do we fail gracefully from that? How do we deal with that in the enterprise? And then when you go to a website and you smash, I want to buy my thing, you expect that to be, I fire off an event and I get back a response. The problem is that if I have a synchronous and asynchronous thing going on and I might have a lot of load, that might be queuing up. We have to have an answer for that as well. And the data thing. So what's some of the key components or some of the key characteristics of a microservice? It's stateless, it's standalone, it's independently deployable. If it has some kind of stored state, it should have its own database to do that, right? That freaks out the data warehouse team because they spend a lot of time finding all the databases in your enterprise and grabbing all the data out, and they need to know the schema. So we need to have an answer for that because we're going to say, sorry, we're going to deploy this all the time, and we might change the schema. We don't have time to notify you because we don't really know what you're pulling. So we have to have an answer for this. How do we keep the data, the data warehouse people happy? So we'll need to talk about that here as well. Because it's the notion of our data is not always persisted somewhere. I mean, you've got the concept of eventually consistent, but I prefer to consider it's in motion. Always something is happening. It might be over here now, and the current state is found by looking over here. The current state now might be over here. We just don't know. And we can't provide a real-time accounting to that. And our data and analytics crew, they provide a very important service. They inform the business decisions in our company, and we need to be able to support that while still being able to deliver the architectures at scale and support the modeling and the team makeup that we want to deal with. And we need to talk about scaling. We need to deal with scaling, right? I saw a good talk this morning. We saw the kind of the scale up versus scale out mentality. If we're in containers, we might be scaling with some kind of container management process or container management system like Kubernetes, Azure Container Service, right? That manages our scaling, or we can scale with AWS Lambda, Azure Functions. So it kind of brings us to the point of cloud here. So. Up until we had a lot of these services that were available to us in the cloud, that were kind of made available to us, we would have to stand up servers, multiple servers, buy software, maintain it, and install it, right? In a smaller shop, there are a lot of small companies, and by small companies I mean, not Apple, right? $10 million company, $100 million company, work with a $20 million company, they have big IT needs. They have a need for an eventing system or an event stream like we're providing them. But if they had to stand up a server farm and support it, they wouldn't be able to do it. So this commoditization of these components, of this scaling model and the ability to deploy and run things into the cloud has allowed us to take event-driven architecture and event-driven systems to a lot more organizations. It used to be you could only do this if you could buy an ESB, or you could only do this if you could make a super highly resilient, RabbitMQ cluster, right? But now with all these cloud-provided tooling, this makes it available to us for anyone. So when I'm talking about orchestrating an enterprise, my first thinking is, let's define events. Let's define messages that we're going to share throughout the system. I've been talking about EDA. I haven't even kind of really defined what it is yet, but we'll get to that here in a second. And I've got to think about how to monitor my system. So if I've got all these asynchronous messages going, how do I know where there's a bottleneck? How do I know where there's a problem or a failure, and then how do I respond to it properly? How, when something inevitably fails, how do I find out where and why it failed, and then retry that work? So we have to think about that and create an architecture that supports that. So now, event-driven architecture. So essentially, event-driven architecture is the components in a system integrate with each other by producing and consuming events. Way back when, my first job at Mediator Corporation in Dublin, Ohio, we were writing Petzold Windows applications and cross-compiling them for the Mac. And we got this new thing called VB3. It was new to us. And we started dragging buttons onto a screen, and we'd click on them, and it would fire up, and it would be a screen. And what I didn't understand is, how does this application start? Where's the main program and the event loop that I'm dealing with? And I didn't really understand that approach, event-driven programming, where I click on event, the operating system will bootstrap the program, and then I'm just responding to these events in these buttons. I didn't get it. And when I got it, I'm like, oh, this is awesome. And then I forgot how to do the other stuff over the years, and now all we do is event-driven stuff, right? On click, even in JavaScript, click event. what we're doing is we're taking that model to the enterprise. We're saying that we have events like customer submits order, and then whoever cares about customer submits order consumes customer events order. Then somebody else might emit a customer billed and the payment received. So the interesting thing about event-driven architecture, now it's a little bit different in an event stream approach. We'll talk about it a little bit later, but at its core, event architecture, everything in the event is everything that needs to process that thing. So what I'm not doing, what event-driven architecture is not, the shipping service querying the enterprise to say, creating a, I don't have this customer, give me their address event, right? That should be encapsulated in the event. When you get the event, everything that the enterprise, that the big architects, and I don't mean big architects, I mean the important architect, the enterprise architects have deemed to be part of this event, are pushing should be in that event. So we need to take care of that. So if I'm pushing an event, it needs to have customer information, for an example. Everything in the event that needs to process that event. So what do we get? We have no point-to-point integrations. We do depend on a common messaging infrastructure, but those non-point-to-point integrations really create a lot of benefit for us. It allows us to operate independently, to deploy independently, to test independently, which means I have loosely coupled, highly scalable systems, and I can organize my teams appropriately. I can have a team that knows about the shipping service, that don't know anything about the invoicing service, but all they know is that they need to consume the order-generated event and consume and produce a, hey, I shipped this event when they ship the thing. Makes these things easier to test, easier to change. And if we're smart about the way that we pick that messaging infrastructure, they can be technology agnostic. And there are a lot of benefits. We'll get into many of those here in a second. Now, I hesitate to leave this slide in this talk. These systems can be, you can think of them as a big state diagram. I'm in this state, this event happens, I'm in this state, right? And that's awesome. Anybody here happen to be a computer scientist, go to computer science school, right? Most of us, right? I show this to a BA and they're like, you're an idiot. I can't do this, right? This is not the way that they communicate. I look at this and I'm like, I get this. This is what I wish we had a long time. I don't like the swim lane diagrams and all that. I get this. An event happens, I go into another state, and that tells me where my process is. But to the computer scientists in the room, most of us, this makes sense. I think it's a way for us to think about how events move through a system. This is a workflow. I create an order, the order submitted, customers billed, I'm ready to be billed. When I receive the payment, I go to verify inventory, make sure I have it, because we always take their money before we make sure we can ship it to them, et cetera, until I'm done with the process. Now we're going to talk about really 3 ways that we can compose an event-driven application. We're kind of talk through three separate scenarios. The first one we're going to talk about is the API gateway. So, we can kick off functions through an API. So you can have a website, an Angular service, an Angular application that talks to an API gateway, and it says, I want to make a new order, right? So essentially, again, copious use of magic move and super fancy animations here. Client makes an order, get a function, they get a response, right? Again, another client, we know how function of a service works. We get a client, they make a request, function is spun up, another client does their thing, and a function is spun up, and when the request is done, it goes away. The problem is, and I saw a good talk today by Chad on Azure functions and orchestrating a process in Azure functions. One thing, if we think about these as services, if the client makes a service, what if the function has to call other functions? Right? What if something has to happen? What if I do, and then I do this and I make a response and then it comes back? So what we're saying is if we're implementing event-driven architecture where really I have a smaller system, what we're doing is we're building an event stream. So what we say is that essentially when a client talks to our system or a person or a website, they're going to use this API. But when our internal components talk to each other, we're going to use events. Okay? That's the basic approach this kind of this API gateway approach. They might be calls to a function, or it could be calls to a website or another API in a Docker container. But essentially, when we're orchestrating this is kind of the simplest approach. We call the API gateway, we make a call to the gateway, it calls the function, and then any orchestration that happens in the background happens in our venting system, so that we can, for example, if we're deploying the function, if it doesn't work, if it's an unhandled exception, those messages will back up, and then we can process them when they come back. All right. Now this is where I am right now most of the time. We're building pub/sub event streams. Okay, so it's this pub/sub model for event-driven architecture, and basically what we're doing is we're replacing that ESB with just a message-passing event stream, so that the events themselves need to be complete. Instead of the event stream saying, "Hey, I need to make a call into the order service or accept a message from the order service in whatever format it gives me," the order service needs to comply or support whatever message is defined by the system. You ever wonder what enterprise architects do, or enterprise application architects do? The best use of their time is not code reviews, picking technology stacks, maybe a little bit, certainly approving, and doing some proofs of concept. But I think part of it also is what they need to be doing is managing this event stream and the event definition, working with the business to do that, to figure out not necessarily the mechanism, yes, the mechanism we use, the physical way we move bits and bytes across the network between systems, but also the logical structure of what messages are coming and how our orchestration, how the whole enterprise orchestration is happening, how our business processes are handled between our different systems. And it's just a side about messages. So I love this model. So if you want to do some beta work, you want to integrate a new system, all you have to do is start consuming the message that you want to consume, right? It's pretty easy to test in production. To bring up a beta version of a service and start processing messages. You'll start getting the messages. And as long as you're not emitting other messages or breaking other people's data, you don't have a problem. So we integrate a new system. It goes live when it goes live. If the message hasn't changed, then I can bring as many messages online, or new systems or new services online as possible. You ever have a marketing company that says, "Hey, we want to change the system that we use for the website, but we still have to get all of our stuff from HR." That's cool. Here's the message that consumes events when new job postings are made. It scales. So, for example, if the inventory system gets backed up, we have a queue and there's 10 million things into the queue. What do we have to do? Well, in a containerized model, we can just, we can tell the container orchestration tool or the container management tool to say, we tell Kubernetes, "Hey, spin up to have 50 of these." And then all we do is spin up more of them, and then we process more quickly, right? As long as we're not sharing databases, this works pretty well. Messages tend to be small. Relative, they look big to us if they have 1,000 lines, but it's really small as the way the world goes. Now, what about the data guys? What about the data and analytics people? Well, what can they do? Can we guess? Well, they start consuming events on the system, and they know what's going on. Now, there's some static systems. Once that data is at rest, once that data is somewhere, they can pull that data out. But the event stream and reporting in real time and dashboards and things of that nature, they can consume events off of the event stream as well. Okay. So if you want to add a third-party integration, you want to add a new, someone wants to be a new client, but they want to white label your service, pretty easy, right? Give them an endpoint and allow them to start emitting messages. If you have a system that's not open, but you really love it, and it's the super awesome system that you use to control a particular machine in a factory, then we can wrap that. We'll show a particular pattern for that here in a second. Sometimes we have to be deliberate about scaling. My friend Bill has a nice story about scaling. He got a $1,000 bill overnight one night from kind of a run on scale. So we have to be deliberate about that. But the net benefit here is if we have a good queuing infrastructure, it's fault tolerant. If my service is down and I'm not processing events, what happens? they just back up. The system's slower, but I should see that bottleneck, and I'll show you an example of that here in a little bit. One of my favorite features is we log the events, and then events can be replayed and rolled back if you're smart. Okay, so if this order didn't go through because it didn't have the right data, or the data was not formed well for the service, and they needed to fix a defect in the service, and they deployed another one, you can replay the event, and it'll go through again. And we can test in isolation. So those are kind of a lot of the points that we were talking about a little bit earlier as far as decisions that we would need to make. So let's look at an example. This is a real architectural concept. If you look at this world, remember our rule. Users interact with a website. Systems, external systems, can consume an API. This is that adapter that we use. We build an adapter that will adapt systems that are a little harder. And then all internal systems, all internal communication happens on this event stream. Okay? This particular example, this is the tech stack. It's an Azure tech stack. Read Angular, read Azure Topics and Subscriptions, Azure Functions, Docker containers, and SQL Azure. We're going to walk through just a quick example of kind of how this information flows through the system. So what happens? An order event is generated by a user. It's generated to the event stream. Everybody that cares consumes that event, and then another service, the invoicing service, says, hey, the customer was billed, and everybody that cares about that responds to that message. It goes to the accounting system, the production system, which is our factory. When that widget has been made, we have the item produced. Then the warehouse consumes that event. Shipping service consumes that event. And you see how the system is flowing? The orchestrations are happening through the system. Shipping service says, all right, I shipped the thing, and the ERP system says, awesome. Warehouse says, okay, I'll take that off my list, and the API consumes that event, notifies the user. Okay, that's kind of how this flows. Now, what's interesting about these little adapter dealios here, okay? They adapt. I would say they're adapter pattern, but they're not. It's not in code. It's a piece of software that makes sure that adapts that software to the eventing system. The original approach was when you were wire up an external partner, they could just consume an API. What we've actually done in this particular instance is that adapter will expose a purpose-built API. That is only for that piece of software that will generate and consume the proper events. I do not take credit for that, nor do I take credit for most of this. There's a guy named Matt Miller, pat him on the back. He did a really good job in coming up with that approach. What that means is that every time we sign up a new customer, we only have to deploy the software that's specific to them, which is the adapter, and not have to deploy whole new routes into an API and do that full level of integration testing. Now, the most important point is the logger consumes every event. So the fact that the logger consumes every event means that I have a record of everything that happens. Now, those logs are horrible to wade through. Every event is in one place, right? Now, we're not talking about the event stream. Hold on to that. We're going to come back to that in a second. Event sourcing, excuse me. But what we can do is that as elements move through the system, we can associate the elements, we can associate the order with all the events that were generated for that order. So if someone says, hey, my order failed, what happened? Well, let's open that order in the monitoring system, and you'll see the events for that order. And you'll see, oh, there was an exception here. We didn't realize that. Someone got an email, someone's not reading an email, and those types of things happen. So what I wanted to do at this point was I wanted to show you, so we have an interesting problem. Of course, not ready. Guess what my password is. I had a whole demo stood up for everybody to say, oh, this is awesome, this is a panacea, this is everything that we want in the world. And then I found out we don't have internet. So I had to make it run locally. So what we have here is we have a RabbitMQ system. We have an in-memory database and 5 services that are sitting here consuming events. So if you look at these guys, let's see if we can do a little zooming here. Of course not. So if you look at these guys, you'll see that they're waiting for events to be processed. So this says the invoicer is waiting for message, and it's waiting for the order accepted event. That's the logger, and it's waiting for all the events. So what we're going to do is we're going to simulate 100 events coming in. So the 100 events start being generated, and you can see the messages start coming across. So nothing's happening in the warehouse yet because it takes a while for an order to get billed, the customer to pay, and the things to come around. What we can see here is that you can see all the queues for all the applications, and you can see how that's working down. So it's pretty easy to see what the bottleneck here is right now. What is it? It's shipping. It's probably the invoicer too, but it could be shipping. So what should we do? Well, let's just spin up some more shippers. Let's spin up some more invoicers. Now, I don't have the ability to do that really easy right here, right now, but pretend that they're all going, well, it looks like it's the invoicer that's causing me problems. Maybe. I don't know. So this kind of what's going. That's kind of what's going on here. So it's kind of super simple. This is a console application, but the idea, if you're writing in Azure Functions, AWS Lambda, is that you have a message trigger or a queue. You have a function bound to a queue, and when a message comes to the queue, it spins up an instance of that function. And I know that's not I've been working with this thing for a while. I wish I could make it faster, but that's why we need to scale. All right, so let's talk about event sourcing for a couple of minutes. So if we go back to this last deal, where this last slide, where the logger gets all the messages. Well, what if my logger could kind of be the whole system? What if the logger was a system of record and had all the messages, shouldn't I be able to go to the log and piece together everything that's happened for my event, right? That's kind of the concept of event sourcing. Essentially, what we're doing is that we have much smaller events like customer name changed, add item to order, customer or credit card number saved, because we all store those, right? Hey, they changed their password. Those are all the micro events kind of that we process. And think of, you could grab all the events for an entity and you could replay them, and you know the state. So eventually what happens is that you generate the event, it's logged, and then you need some mechanism that takes those events, munges them together, replays them, and gives you your state, right? It embraces the notion of CQRS, command query response segregation. Sometimes I get the R wrong, by the way. So that we query we execute commands in one set of code, we query in another set of code. What do we query against? We query against the memory store, against the eventually consistent store. So here's what we have. We essentially have a service, and by the way, this comes from a book called Microservices with Clojure. We have systems that publish and consume events, but we also take all those transactions, and dump them into the event store, and then we take that event store and we move that data into a read query, right? To a read store. So that we can consume those events. It's the thing that I thought of when I first I heard about this after I heard about blockchain, and I think about it that way. We have transactions, we have to replay them to get the state. So how do we keep the data and analytics people happy? And rightly, they should be happy, by the way. It's because they're going to pull from that read-only store. This is kind of the ultimate version of data in motion, right? We're just archiving the transactions, we're archiving the events, and then we're using those events to update the state in another read store. We're not reading from the transaction store. Now, that also means it's potential that we're also producing and consuming events. That doesn't mean there's not an invoicing system that's consuming a new order event or an item added to order event, right? But we're also bringing those out here, and all of our reads are coming from from the event store. Now, I hear, I think the tooling's not totally caught up to me yet for this. A lot of people are creating, implementing event sourcing with Kafka. As far as, it's really good at streaming the events and logging the events. I'm not smart enough to create my own tooling. I don't have a system that this solves the problem for yet, or a problem that this solves yet. And it's probably because I'm not good at it yet. Okay, we're doing fine sometimes in pub sub and orchestrating in that way. We have tooling, we have knowledge, we have internal information. But as we deal with high volume systems, super high volume systems, internet scale systems, I can easily see where an event sourcing design would be somewhere that we need to be, something that we need to consider. All right, so that takes us to then. I've done some dabbling in event sourcing. I've done most of. I started out with an API gateway and graduated as I needed integrate more systems, and I wasn't just talking to a client. Right now, I'm in this eventing world where we're executing pub sub models with SNS and AWS or Azure Event Bus. I think it's called. Yeah, I'm at that age. I'm at a weird age where my glasses, to see you, I need my glasses. To see my computer, I don't. And proper nouns are gone. They're just gone. I don't know, but at any rate, and then event sourcing. So the work that I'm going to be doing more recently is to figure out where event sourcing is going to fit and where does it fit in our world and our process orchestrations. There's a lot of stuff here. I'll have a QR code here in a second that'll link to the presentation. I will update the presentation, store the presentation in the GitHub service as a PDF because this is Keynote. Not everybody's dumb enough to use Keynote. And then there's some articles that are here and a couple of books, and they'll be linked. Are there any questions? Any questions for me? Yes, sir.
Yeah, if you have a need to do the aggregation, like back on your couple slides ago, you had the transaction event store.
Yes, sir.
Would you aggregate off that, or would you hang another aggregator off?
We're gonna take the events. No, you could, okay, but you could. Then that's maybe an implementation. But kind of what the universe is saying is that we're going to do it this way, and then we're going to have somebody that consumes all those transactions and construct the read store. Yeah. Any other questions?
Yeah.
Yes, sir.
So you said that the publisher basically puts everything in the message that's needed in order to consume it.
Yeah.
But does that then not make the publisher cohesive to all the panacea?
So the assumption is if you can publish the event, you have the information that's necessary for that event.
So the consumers may still need to do other queries
Well,
related but not directly.
but what we're not doing, yes, yeah, I see your point. But what we're not doing is we're not going to query the event. We're not going to execute. We're not going to say, "Hey, consumer, give me the event." Right? Now we could do a new order event. Okay, great. And then the customer service says new order, consumes the new order event, says, well, somebody might not have all the most recent customer information, and they generate another event, and then your processor, your invoicer, gets the new order event, but it can't process it until it receives here's the customer here's customer information updated event. Okay. Now there's also could be replication. So for example, if the CRM system says the customer address is 1234 My Street, and then they change the address to 1234 Your Street, they should generate a customer information event change because it might be that you need to maintain customer information in more than one place. Okay, even though it's not the system of record. Okay, that's part of that. Code reuse is not your friend. The data reuse is not always your friend as well. Does that answer your question or get you going? Is there a follow-up? Huh?
I just said it gets hairy.
It does, but we have to think about it from how do we move information through the system and what needs to be a part of that information. Any other questions? Yes, sir.
Yeah, if you're leaving the message in the queue for multiple subscribers, how do you prevent the system from processing the same message multiple times?
Yes, so the queuing system will support that, right? But we're generally not connecting we're not having multiple subscribers on one queue. We're having multiple subscribers with their own queue that just happen that both queues get the same message. So if I'm the logger, I have one queue where the message goes, and if I'm the invoicer, the same message goes in both queues.
The publisher has to be aware to put this on multiple queues.
Yes, and that's the topics and subscriptions is in RabbitMQ, what it would be. You would execute your topic would be your event name, and then you would say, hey, I want things in my queue, I want to have these topics. Does that answer your question? Yes. Okay.
You have one from GitHub, or from Slack.
Okay, from Slack?
Well, you have two. The first one is, will you be sharing your GitHub or QR code on Slack? Can you do that?
Yes.
Okay. And
Yes.
then the other one is, do you have any advice for managing versions of events?
Yes. Events need to be versioned. So you need to subscribe to specific versions of events. So if you're consuming a version 1, if you're consuming an event and I need to change the definition for the event, cause a problem if I decided to support Canadian zip codes. So I need to have version 2 of the event or version 1.5 of the event. That would get me going. So I have to version the events. Events have to have a version and probably a payload that you define internally that it's an envelope that tells you some things about the event, and then you need to consume certain versions of that event. A benefit of that is that you can be producing and consuming both versions of the event, and you can do beta testing right against that stuff, be consuming real events out of that. Saw a question up here.
Do you ever have events with sensitive data where you only want certain consumers to be able to see that event?
Do we have events with sensitive data? I haven't run across that, but the answer is yes. That's something we haven't considered and we haven't dealt with. I've been about 3 or 4 years of doing this, 5 or 6 implementations, and we haven't dealt with that super secret stuff yet. Now, we have taken super secret data and it goes encrypted in encrypted form on somewhere on a network, right? Like a cloud data store or a file system or something like that, and that information will be out there, like a document or a license code or an invoice, something like that. Yes, sir.
With the event stream being so critical, do you have like rules of engagement with people when they start using the event store?
So the question is, there rules of engagement of interacting with the event stream? We have to have rules, and we have to support our capacity. Right, or we have to support the capacity that's given to us, or that we need to support, and people can abuse that. Now, as far as we can probably limit the number of messages that are generated in a certain time quantum from a particular source, right? I haven't done that.
You do things like tell systems don't use this as your processing queue, pull it off the queue right away.
So what we have done is that we've limited the number of instances that can spin up that process messages, right? So you're probably not clogging up somebody else's queue, but you could be, right? So if you have a particular subsystem and you're passing messages from one system to the other system through the event stream, and they're not supported by the system, meaning then we've got a problem, right? Then we haven't defined them and thought about them specifically. People just can't randomly start dumping messages onto the queue, or onto the event stream that nobody else knows about. One, they won't go nowhere. They won't go anywhere. They'll be eaten by the system. And 2, nobody will have a queue stood up for them, because that's usually something that we would sculpt in Terraform or whatever our scripting tool is that stands up this messaging environment. So we would say, hey, we have a new need, we have a new event, and we need and the new application wants to process that event. We'd put that in our script, and we would update, and that's the only way that would happen. Other questions? Yes, sir.
Just curious about the potential for events being carried out with losses tied to the event store.
So say that again, a little bit louder.
I'm just curious about the potential for having events being carried out by a service or company,
Yeah.
but not making it to the event store.
Yeah.
Have some network issue or use the system between.
Well, the event generator, so the question is, what if we can't talk to the event store for whatever reason? That should be an exception in the application that, or in the adapter of the application that sends that event. It should know that it didn't get the acknowledgement that said, I got your event, right? That's one of the reasons, one of the key reasons why I really like the eventing model is that our messages will stack up. But the keyest component, I like an event stream over an event ESB, Enterprise Service Bus, is because the only thing the eventing system has to do is pass messages. No transformation. It doesn't care if the data formats are bad. It doesn't matter. It comes in as text or serialized binary potentially, and it goes out. It just gets routed in that way. If it's down, the applications that are consuming or generating messages should be down. So the thing we could do here in our example is I could stop RabbitMQ, and I should start seeing my applications start to be angry with me next time they start trying to get messages. All right, any other questions? I think we're... So I'll publish all this. The request was, can I put the QR code on Slack? I'll do that here in just a second. And I thank you for your attention. Thanks for coming. I hope you enjoy the movie. And I'm interested to hear how event-driven architectures are working for you. Thank you.